Hello everybody, welcome back to another video. Today we're going to be talking about the AP Calculus BC 2025 FRQ number 1. Let's get right into it. Alright, so this is known as the famous invasive species of a plant, FRQ, and many people struggled with this, so hopefully you can check your answers if you remember it, and you're on that road to a 5, okay? So let's see. Let's read right from the start. Number 1. An invasive species of a plant appears in a fruit grove at time t equals 0 and begins to spread. The function c is defined by c of t is equal to 7.6 arctangent of 0.2 times t, which models the number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that the first derivative of c prime of t, is equal to 38 over 25 plus t squared. Calculator should be in radian mode. Part A. Find the average number of acres affected by the invasive species from time t equals 0 to time t equals 4 weeks. Show the setup for your calculations. So, essentially, you can see right here, we have our main function as a function of t. If you're a calc student, you should realize that this should be your variable of integration, or what you differentiate with respect to. That should be an alarm going off. And you can see the C prime indicates that we might have to do something involving rate of change. So make sure we understand the problem first. We have an invasive species, and it's just the function c is modeling the number of acres affected by the species t weeks after the species appears. Biggest thing. So for part A, average value, your formula for average value is as such. 1 over b minus a, integral of a to b of f of x dx. You integrate over your bound from a to b. Conceptually, it makes sense too, because if you have a function, a is here, b is here, you integrate this area and you divide by this amount. So you can get the average value of that function on that interval. So when we see our question asking for average value, you should be thinking of that immediately. Now, the answer to this is very straightforward. We have 1 over, what's our right bound? Our right bound is 4, because t equals 4, and our left bound is 0. The key word in this problem is average. So our formula is now 1 over 4 minus 0, integral from 0 to 4, that's what we're integrating over, of c of t dt. And this is a calculator allowed question, so you can literally just plug in this function, plug in this exactly into your calculator using your fraction, and then math 9, and then you would have got the answer. And c of t you replace with 7.6 arctan 0.2 t. This should give you roughly 2.778 acres. So if you remember that, there you go. Now, part B. Find the time t when the instantaneous rate of change of c equals the average rate of change of c over the time interval from 0 to 4. So, many keywords in this. One of them is instantaneous. Instantaneous just means derivative, because that's what the instantaneous rate of change is. Average rate of change is just your typical slope formula. y2 minus y1 over x2 minus x1. So let's set them equal to each other. Our average rate of change is just going to use the slope formula, which where we plug in our bounds. Our bounds are 0 to 4 again, so I can simply do c of 4 minus c of 0 over 4 minus 0, which gives us our average rate of change on this interval. This is going to be, we're going to set this equal to c prime of t. Now, this is a value that we can compute because we're given the function. So when you plug this into your calculator, you will get c prime of t. You're trying to solve for when c prime of t is equal to roughly 1.282. And you can use the exact value in your calculator to get the exact value. Now you're going to set this equal to 38 over 25 plus t squared, because that is what c prime of t is defined to be in the problem statement. Once you're doing that, you can use your calculator to graph the function of this, and you just have to solve for when t matches. But you'll get t is roughly equal to t is roughly 2.154 weeks, just like that. And College Board does not care too much about the squiggly equal sign, or approximately. If you wrote equals, that's fine. So yeah, moving on to part C. Very simple. And a lot of this is just understanding the problem statement. You just have to slow down sometimes and understand what it's asking, and then you can solve it. Part C. Assume the invasive species continues to spread according to the given model for all times t is greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. Again, this is very straightforward. It's telling you exactly what to do. Write a limit expression. And what do they want? So limit, I recommend that you underline and circle words as you read them to really help you understand. It's a very good way to do this. On your other AP exams in the future, just general good test taking tip, and it'll really help you understand. So write a limit expression that helps describe the end behavior. End behavior just means as t goes to infinity. So you write exactly that. Limit as t goes to infinity of what do they want? They want the rate of change of the number of acres. So this is just c prime of t. C prime of t. And this is going to be equal to the limit as t goes to infinity. We just plug in the function. 38 over 25 plus t squared. What happens when t grows and grows and grows and grows? This is going to approach, because this is the limit, I can write this with an equal sign. Limit as t approaches infinity of 38 over t squared. And that's perfectly fine because it's with the limit. If they remove the limit, this is not true. But the end behavior is as t grows, this entire thing approaches 0. So yeah, that was answer to part C. Finally, part D, arguably the hardest. But at time t equals 4, after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function a, defined by a of t, is equal to c of t minus the integral from 4 to t of 0.1 times ln of x dx, models the number of acres affected by the species over the time interval. 4 is less than equal to t, which is less than equal to 36. At what time t for this interval does a attain its maximum value? A lot of stuff going on here. To conceptualize the problem first, what we have to do is just understand our function a. That's the number one thing. What is a? They said that a shows the number of acres affected by the species over the time interval. And this expression right here, this integral, is showing those measures to counter the spread of the species. So, and what do they want from us? They want us to find the t value when a is maximized. And then they want us to justify. Keyword, justify. So what is one way we can do this that we learned in calculus? We learned that if we have a function like this, for example, not necessarily any trigonometric, but we have anything like this, at this point where it attains a little relative maximum here, now I don't know if it's the absolute because the function might do stuff later, but relative maximum, the derivative is equal to 0. But even at the relative minimum, it also attains 0. So these are called critical points, and these are used to evaluate potential positions where you can find maximum. So if they want us to maximize a, that means we have to set the derivative of a to 0. So we can say a prime of t. What is a prime of t going to equal? Well, let's derive each component by doing it separately. A prime of t is equal to the derivative of c of t, which is just c prime of t. And then what's the derivative of this integral expression? Integral from 4 to t of 0.1 times ln of x dx. Simple, you just remove the integral there. Because the bound is t, it's not t squared or t cubed. You don't have to worry about chain rule too much here. So it's literally just whatever is inside of the integral, which is going to be minus 0.1 ln of t. And it's a function of t, because remember, don't put x by accident. That makes it all wrong. This is the variable we're integrating with respect to, but this is in the bound. So once you integrate this, you're going to get a function of t. Therefore, when you take the derivative, you're going to get a function of t as well. So we have a prime of t is equal to c prime of t minus 0.1 ln of t. Now we're trying to set a prime of t equal to 0, and then we can solve for t. So let's do this. C prime of t is equal to what? They gave us c prime of t at the start. 38 over 25 plus t squared. And if you set this equal to 0, this entire expression, you can set this equal to 0.1 ln of t. Now, because your graphing calculator is allowed, this is where you need to use your calculator to find the answer, to get to that point, hey, what does t equal to? If you try to do it analytically, you won't be able to. So you graph both functions, you graph this, you find t. T's value, I have it right here, t should approximately be 11.4417. And this is probably going to be a relative maximum. But we can't stop here. Biggest mistake is people just say this is a relative maximum and we're done. What did we forget that's part of the problem statement? It says justify your answer. And we don't have enough information to conclude that this is a relative maximum just by saying it might just be. So we can further prove this by looking at some values of t. Let's say we create a sign chart. If I have a sign chart like this and I label this as a prime of t, I have my value 11.4417, and I have my bounds 36, and I have 4 here. And I plug in some value of 6, or I don't know, plug in some value of 15. It's in between these bounds. Now, College Board doesn't grade these sign charts anymore, but this is used for your own understanding to see if this is really a maximum. So you can state some justification after that. So what we can do is we can plug in values for t at a 6, for example, and we have our function, so you can do so accordingly. And what you're going to find is a prime of t is going to be positive here, and it's going to be negative here. And what does that mean for a of t? And by the way, if you're confused what I just did here, I took a value of 6 that lies between our 4 to 11.4417, and I plug it into a prime of t, because we have our c prime of t function, and we have this. And you're going to get a positive number. You do it here, you're going to get a negative number. That means a of t is increasing here, and a of t is decreasing here, which means that this is a relative maximum. A relative maximum right there. So we don't know for sure if this is going to be our absolute maximum. And why do we not know? Because when we evaluate critical points, we also have to include the endpoints in our check. So we have to check for that separately. We can see that a of 4 right here, which is one of our endpoints, is going to equal just whatever we plug in. So a of 4, let's calculate it. That's one of our endpoints. That's going to be equal c of 4, based on the problem statement, minus the integral from 4 to 4 of 0.1 ln of x dx. Now, do you see something we can do here? If you got it, you can remove this integral because it's an integral from 4 to 4. So this turns out to be 0. A of 4 is equal to c of 4. And c of 4 is approximately 5.128 acres. So that is one thing right there. That's what the value of a of t is at that point. A of 36, which is our other endpoint, you can plug this in. You will get approximately 1.743 acres. But then that leaves us the question, what is the value of a of t at our point, which we concluded was the absolute maximum? Let's find it. A of 11.4417 is, and by the way, to do this, you just plug it into c of t and this integral all into your calculator. And that's how you check these endpoints. This is going to equal roughly 7.317 acres. So you can clearly see that it exceeds our 5.128 and our 1.743. So are we done here? Have we done everything? Is College Board going to give us a 5 for the perfect score for this FRQ? No, not yet, because we still have to, after all of this, we still have to justify our answer. So the final part of part D, you can put this anywhere on your sheet. All you have to say is t equals 11.4417 weeks, which is the units. And this is going to be, they want our, at what time t? So they want the time t for which a attains the maximum value. T equals 11.4417 weeks is when a of t attains its maximum value, which is true. But why? Because a prime of t changes. So the keyword is changes from positive to negative. And one last addendum, a of 11.4417 is greater than the endpoints, and you can write it like this: for greater than a of 4 and a of 36. So the key points to acing this FRQ in part D was saying that you're saying what t value it is, which is what the question asks, saying it attains saying it attains the maximum value. And why does it attain maximum value? Because a prime changes from positive to negative based on our sign chart. We can't use this sign chart in our justification. You can't say our sign chart says this, because they don't grade that anymore. But it changed from positive to negative, and this exceeds all the endpoints. So if you did that, you would have properly justified what the maximum value was, and you're done with FRQ number 1. I hope you guys enjoyed this video. If I didn't explain something too clearly, let me know down in the comments below. I can help with that. If you have any future video suggestions, let me know. Of course, drop a like, drop a subscribe. Please subscribe and share the video. Thank you guys so much. Have a great day.